Oh my god. Daylight savings is like horrible, bro. I'm just so tired. My workout today was horrible. My sleep today is horrible. Okay, let's do the video. Okay, so let's go find the vector equation of a line that intersects two planes. So, given this plane, x plus 2y minus z is equal to 3, and 2x minus y is plus 3z is equal to 1. So there's two ways that you can solve for the vector equation of a line that intersects these two planes. But one of the ways that you can is by either finding 2 points on the line and then solving for the vector between those 2 points, or finding 1 point on the line that intersects the planes and also finding the cross product of their normal vectors. And that answer of your cross product for the normal vectors will be a line that is parallel to both ways. But I will use both methods for this video for multiple different questions. But for this one, I'll find 2 points. So how am I going to do that? Well, on the line that intersects these two planes, there will always be some point that where x is equal to 0, y is equal to 0, or z is equal to 0. And if not, if x can't equal 0, because there's some cases where x can't equal to 0 for the intersections of the planes, y and z can be equal to 0. And in some cases where y is equal to 0 cannot be true, x equals 0 and z equals 0 have to be true. So for this one, all cases of x, y, and z being equal to 0 work for these equations. So for this, we don't have to worry about that. But we can actually set z equal to 0 first, and then all we get is a system of equations. So if you're a scholar, go pause the video now and solve for the rest using that hint. But if you're not, it's fine. Let's multiply this top function by 2 to get 2x plus 4y is equal to 6, and leave the bottom function the same. And I'm just going to use elimination here to solve the system. But in this system, getting rid of 2x, you get 5y is equal to 5. So y is equal to 1. And when y is equal to 1, let's plug in y equal to 1 into this equation here. And then you get x is equal to 1 as well. So that's one of our points here. Point P, let's call it. So point P is 1, 1, 0. Let's actually use a different color for that. Let's write down the equation again. 2x plus y minus z is equal to 3. 2x minus y plus 3z is equal to 1. This one, let's just set y is equal to 0. So when y is equal to 0, all we get left off with is x minus z is equal to 3, and 2x plus 3z is equal to 1. You multiply this top function by 2, and then you get 2x minus 2z is equal to 6, and then 2x plus 3z is equal to 1. If you subtract, what just happened? What just happened? My pen is stuck. Okay. Why is it in zoom mode? Oh, it switched for some reason. Okay, let's go back. So, if you subtract these two systems of equations, 2x gets eliminated, and then you get left off with 5z is equal to 5, and z is equal to negative 1. So your y is equal to 0, z is equal to negative 1, and x is equal to, and let's just plug in z into negative 1. So let's draw an arrow for that. equal to 3, so x is equal to 2 here. So our 2 points are point Q, y is equal to 0, 2, 0, -1. And given these 2 points, let's actually erase everything. I'll just leave the function up top though. And given these 2 points, we could find the vector equation for the line. How can we do that? Well, for the vector equation of a line, and let's actually clear this up. This was z and 3z, right? Yeah. This looks like a 2. Let's write z. So for the vector equation line, all you need is 1 point and a vector that is parallel to the points. Parallel to the line, I mean. So in order to do that, well, since these 2 points are on the intersection of the 2 planes, we can actually just find the vector between P and Q to get the vector that is parallel to the lines. So this is 1, -1, and -1. And we have a point. Let's use point P for this. So all we need is point P plus T times the vector that's parallel, and this is the equation of a line. That is parallel to this guy right here. I mean, intersects this guy right here. Okay, let's move on to the next problem. So for this problem, I'm going to use the normal vector method in order to solve for the equation of the line. I mean, the vector that is parallel. So for this problem, this is 2x minus y minus y plus 2z equals 6. And then 3x plus y minus z is equal to 4. So, how can we do this? Okay. Let's get the normal vectors first. So, normal vector for this is, what is it? It's 1, -1, and 2. Normal vector for this guy is 3, a better looking 3, 1, -1. So the normal vector, let's calculate it, is 1 minus 2, 6 plus 1, and 1 plus 3. And if you simplify everything, all you get is -1, 7, and 4. So this is our vector that is parallel to the line that intersects these 2 planes. What do? Now we just find a point. Let's just rewrite the entire thing. And previously we found a point by setting any of the variables to 0. And for this one, let's just set z is equal to 0. Again, I just like setting z equal to 0 first. It's just a preference of mine. But let's go ahead and rewrite this equation. This equation is rewritten to 3x plus y is equal to 4. And all we have to do here is just add these 2 equations. Y gets crossed out, and then we get 4x is equal to 10. So x is equal to 5 over 2. And for this, let's plug in 5 over 2 to this. Minus y is equal to 6. Y is equal to -7 over 2. So for this guy, we have a point. So this point, let's call it point P. X is equal to 5 over 2. Y is equal to -7 over 2. And z is equal to 0. So now that we have 2 out of the 2 things that we need to write the equation on the line, let's go ahead and write it. So we start off with the point, and then we just find, and then we just put the vector that is parallel to the line multiplied by t. So this is our answer to the vector equation of the line that intersects these two planes. One more. X plus 2y minus 3z is equal to 9. 4x minus y plus z is equal to 2. So let's find the vector that is parallel. So the normal vector, normal vectors are 2, 4, -1, and 1 for these two planes. And I'm going to solve for the normal vector. So solving for it is this guy. -12 minus 1 and -1 minus 8. Simplify this vector, we get -1, -13, and -9. I want this to look pretty, I'm not going to lie, so I'm just going to scalar multiple all of these. This vector is still parallel to this one up above, but no negative number, so it just looks prettier. Let's solve for 1 point on this graph, or on this line. So this one point, I'll just set z equals 0 first again, just preference. So z is equal to 0. And let's rewrite the function. X plus 2y is equal to 9. 4x minus y is equal to 2. And if we multiply the bottom function by 2, we get x plus 2y is equal to 9. And 8x minus 2y is equal to 4. Okay. And then if we add these two functions, why am I using orange? The y variable gets canceled out, and we get 9x is equal to 13. So x is equal to 13 over 9. And let's plug in x equal to 13 over 9, and I don't know which function's easier. Let's just use the top one. So let's use the top one. 13 over 9 plus 2y is equal to 9. Now that we have this, what the hell happened? Okay. Let's just solve for y. What is this? 81 minus 13 is 68. So we get 2y is equal to 68 over 9 divided by 2. And then y is equal to y is equal to 68. Let's divide it, 34 over 9. So now that we have a point, so let's actually draw the point here. This is our line that's parallel, but let's draw the point, or just write it explicitly down. 34 over 9 and 0. Now that we have this point, we can write down the vector equation of the line. So 13 over 9, 34 over 9, 0 plus t of the normal vector. I mean the vector that's parallel. I keep saying normal vector. The vector that is parallel to the line, or the vector that is parallel to the intersection of the line of these two planes. So what we did, let's do a quick recap. What we did is find the two normal vectors, solve for their cross product over here, and then found a point. And using the cross product, which this cross product is parallel, so goes in the same direction as the vector that is intersecting these two planes, this guy can be plugged into the vector equation, the line. And all we did was set z is equal to 0, solve for x and y, and then we have a point that is on the line as well. And once we have a point and a vector that is parallel to the line, all that we have to do is put things together. So, if you have any questions, put it down in the comments section. I'm tired. I'm going to take a nap.